Good morning, everyone. Happy Wednesday. Today we're going to look at another one of our vector word problems. Just like yesterday, we're going to work through one of these together. I have a copy of this exact question in our Google Classroom, so print it off or just kind of read it, however you need to do it to get through this question, and we will do everything we can. Tomorrow is going to be kind of your review on the word problems. We're going to try today to break it down into a few steps, so hopefully it's a little bit more routine. But I know this stuff is kind of weird, kind of hard, but as with everything math, once you hit the application stuff, that's typically how it ends up being. So we'll take a look at this one. It says an airplane is traveling at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude with negligible wind velocity. As the airplane reaches a certain point, it encounters wind blowing with a velocity of 70 miles per hour in the direction north 45 degrees east. We want to find out what are the resultant speed and direction of the airplane. Okay, so first thing I'm going to do is I'm going to start with our Cartesian plane and kind of draw where these things are. So if we take a look at the first part, so here's just our normal graph. So I know that I've got this plane traveling at 500 miles an hour, bearing 330 degrees. So in what we remember about our unit circle stuff, 330 degrees is going to be right about here. Now obviously mine's not going to be perfect, it's not going to be exact, but the big thing is to know that it's going to be in the fourth quadrant and that this has a measure of 330 degrees. And that this length of this magnitude for this vector is 500 miles per hour. Okay, so that's the first part. And then it talks about this wind. This wind is coming with a velocity of 70 miles per hour at a direction of north 45 east. And like we talked about yesterday, north, west, south, east. So north 45 east puts the wind blowing kind of this way. Remember, since I'm measuring north 45 east, this is the 45 degrees it's talking about. Now, the nice thing about this problem is it's just coincidental that since each quadrant is 90 degrees, this angle for my vector is also going to be 45 degrees. So like I said, that's mostly just from luck. So here is my plane, and here's the wind. So I know that because the wind is acting on the plane, the wind is really going to be pushing my plane here. So the true direction of my plane is really going to be more along this line here. So this is the vector that we're trying to figure out, this kind of dotted dashed one. This is going to be the true distance, the true speed, the true direction that this plane is flying in. Okay, so the first thing that I want to do is I want to figure out the plane's coordinates. I want to figure out this terminal point right here. Okay, so to do that, since I'm talking about my plane, I take the magnitude of the plane. Well, the magnitude is at speed, 500 miles an hour. And because we're kind of equating this to our unit circle, it's going to be cosine of theta, which for my plane is 330 degrees. And 500 sine theta, which again is 330 degrees. So if we look at this on the calculator, 500 cosine 330 gives me about 433. And 500 sine theta gives me negative 250. Now remember, we're saying that our plane is in this fourth quadrant, and what we know about quadrant 4 is that x is positive and y is negative, so our answer makes perfect sense. Okay, now let's take a look at the wind. For the wind, it's going to be the same idea. My wind has a magnitude of 70, and it's saying that it's blowing with a 45 degree angle from our positive x-axis. So it's going to be 70 cosine 45 and 70 sine 45. So 70 cosine 45 and 70 sine 45. Now, if you notice, these two answers are the same, and if you remember your unit circle, that hopefully makes sense, because we said that because at 45 degrees on our unit circle, that it had coordinates root 2 over 2, comma, root 2 over 2. So it should make sense that I'm multiplying 70 by root 2 over 2 and 70 over root 2 over 2 and getting that same answer. So, again, I'm just going to go ahead and I'm going to round this to just 49 for both. Again, my wind is north 45 degrees east, so I know it's in that first quadrant where both my x and my y are positive. So that makes sense. Now what I'm going to do is I want to find this linear combination of those two vectors when the plane is being pushed upon by the wind. That's what I'm looking for here. So the first thing we do is I'm just going to add my two answers together. I'm going to add this number with this number to figure out the true course of the plane. So that's, pretty simple math. I'm just going to take those values and just add them together. So 433 plus 49 and negative 250 plus 49. And when we do that, like I said, it's a pretty simple calculation. 433 plus 49, that gives me 482. And negative 250 plus 49 is negative 201. So that tells me the true terminal point of my plane is going to be at the location 482,201 as being pushed upon. Okay. Now what I want to do though is I want to figure out the direction in which the plane is truly flying in, as well as the true speed of the plane, taking into consideration the wind. So there's just two steps for this. The two things we have to find, first is I'm just going to do my inverse tangent of negative 201 over 482. Now right away I know that this is going to give me a negative answer. Remember, we want to convert all of our negative degrees into positive answers, and we'll remember how to do that in just a second. But I'm going to do tangent inverse of negative 201 over 482. So I get an answer of negative 22 degrees. So that negative 22 degrees is going to be this part right here. So because this is my clockwise direction, to figure out my positive one, I want to go counterclockwise. So I'm going to take this negative 22 degrees, and let's round it to negative 23. And I'm just going to add 360, because remember, we're talking about coterminals and those kinds of things. So if I do, negative 23 plus 360, we're going to get that the true bearing of my plane is 337 degrees. The second thing we have to do is we just want to figure out the actual speed of the distance. The speed in this case is going to be the magnitude. So I'm just going to do the magnitude of the direction of my plane. So it's going to be the square root of 482 squared plus negative 201 squared. So, like I said, I'm going to do this calculation. The square root of 482 squared plus negative 201 squared. So, square root 482 squared plus negative 201 squared. And I get them. This plane is really traveling at a speed of 522 miles per hour. Okay, so hopefully that makes sense. Like I said, watch this video once or twice if you have to. The big steps that we do is first, I want to figure out the coordinates for the plane. Then I figured out the coordinates for the wind, and that's for that terminal point. We add them together. And once we add them together, then I just figure out my true angle, and then I figure out my true magnitude. So 5, hopefully pretty quick, easy steps. Okay? If you have any questions, today from 11:30 to noon will be another one of our virtual classes. Tomorrow is going to be some Edulastic practice with these. Maybe Edulastic, maybe I'll find something different. Hopefully I can find something different. And then Friday is basically just going to be a work day to get everything caught up. So hopefully, another coursework wise, easy week, but this stuff is kind of hard, so it's a little mentally more difficult. So if you have questions, let me know. Stay healthy, stay safe. See y'all.